In this lecture, we will talk about two examples. One is that find the eccentricity of the hyperbola x squared over 16 minus y squared over 14 equals 1. This one, if we remember the definition of eccentricity, then we are fine. Okay. First, we need to do is change this one into the standard form. You see, 6 is 4 squared, and 14 is radical 14, and then you square it. Okay. Again, here is hyperbola. Whoever is positive in front of the coefficient, in front of the variable, whoever you get coefficient is positive, then down below, that one will be a squared. Okay. So here a squared is 4 squared. Okay. And then b is actually radical 14. Again, in hyperbola, c is the biggest. So a squared plus b squared is c squared. So it's 16 plus 14, you add together is 30, which is c squared. You get c, you have to choose the square root. So for a given function, we can always find out c with, you add those two, choose the square root. Okay? Now, the eccentricity is defined as c over a. That's the definition. Try to remember that. Again, how do you remember it? C normally it tells us the for C. A it tells us the vertices. AC are always on the same axis. Okay? Yeah. So then in this way, you do is C over A. It's always C over A in both ellipse and hyperbola. Okay? And also in ellipse and hyperbola, C and A is always on the same axis. Okay? So here C is radical 30 and A is 4. You just calculate it. Okay? So you turn on radical 30, close parenthesis, divided by 4, which is 1.36 something. You round it up, you have approximately 1.4. Okay, this one sounds easy. Okay, as long as you remember the definition. Now, second one is find the equation of hyperbola with vertices at 0, positive, negative 16. And asymptotes is y equals positive, negative for x. Okay? Yeah, down here we know vertices gives us what? A, okay? 4c gives us c, vertices gives us a. Yeah. Now, this point is on y, since x coordinate is 0. So those 2 points, those 2 vertices are on y. So somehow if this is y, the graph, one branch up, one branch down. Okay? So you will have that in your mind. So basically it's like that. One is 0, 16 here. That gives you a. Another is like this, 0, negative 16. All right? Yeah. So let me put one more bracket here. All right. Now, again, remember, A and C, if we want C, but we don't want C here, is what? A and C always are on the same axis. Okay, so the one of the foci is here, another focus is down below, right here. Okay, and what B you can find out, I will show you later, but you know B will be somewhere here. So in this case, rise over run, rise is A, run is B. Okay, so it tells us what? The slope A over B, not B over A. Because of what? A is right here, is like this one. So rise is A and run is B. Okay, so rise over run is A over B, not B over A, is 4. Okay, so A over B is 4. All right, and then you do times B on both sides. Cancel B here, A stands alone, and A equals 4B. Again, upstairs, this basically tells us 16 is A. Okay, now, actually from here, A over B is 4. You have that, and then you plug in A here, because A is what? A is 16, and 16 equals 4B, then both sides divided by 4. You can have a B comes out. Okay, B comes out, B stands alone on the right. 4 cancel, so 16 divided by 4 is 4. All right, you have A and B, you can write the equation. Okay, A in front of A, first of all, this one is vertices on the y-axis. Then you know this 16A is down below y with positive. Okay, so y squared over 16 squared minus x squared over 4b in front of b squared is always negative. Okay, in this case, because we were told whoever is what? Whoever is positive, whoever will be A. Okay, yeah. Now, you may do is you may expand 16 to 256 and 4 to 16. That will be y squared over 256 minus x squared over 16 equals 1. That's the second example. All right. I will keep this lecture short. See you next time.